Morning, everybody. It's great to be here. Thank you to Manu, thank you to the Columbia Water Center. This has always been a great event. It's always a really diverse set of people. It's wonderful to catch up with people, especially in 3 dimensions. I know that there's a virtual audience as well, but welcome. And I've known Radhika for a long time, and I just, a personal comment, it's just great to have someone like Radhika at EPA. She's been committed to water for a long, long time. She's not your traditional water bureaucrat. It's wonderful to see what EPA has been doing and to catch up. So I have just a few minutes to try and set the stage to frame the day, really in the broadest sense. I should note, John mentioned my book. Manu was very nice and bought a whole bunch of books that are, I think, available for free out there for you. And I'm happy to sign them later. But I'm going to talk a little bit about the book because it's a way to, in a sense, frame where we are today. As you know, water is connected to everything we care about, to food, to climate, to human health, to ecosystem health, to extreme events, to energy, to human rights, and to more. It's what's kept me working in this area for a long time. There's no shortage of issues to think about, challenges to deal with. And it's one of the reasons I suspect everyone else is here. And I'd like to start really by saying that we're facing a series of difficult, interconnected water challenges now. And I'd like to also state, as I state in the book, that I think we can solve them. And in fact, I believe we're going to solve them. In the book, I describe 3 ages of water. And the first age extends all the way back to the Big Bang, to the beginning of time as we know it. It turns out that the very first molecules of hydrogen, we think were created within literally perhaps a few minutes after the Big Bang. And oxygen took a little longer. The first stars had to form. They grew old, they blew up, they created oxygen the way stars do. But once we had hydrogen and oxygen, we had water. And everywhere we look now, through our solar system, through the galaxy, through the universe, it turns out we find water. There's water in the craters of Mercury near the sun. A few weeks ago, in a remarkable technological event, India landed a rover on the moon. And the place they chose to land it was near the south pole of the moon, where we've seen water in deep craters, water ice in deep craters. There's water on the ocean moons of Saturn, Neptune and Uranus, not particularly large planets, actually have more water on them each than there is here on Earth. There's water basically everywhere we look. And the first age also included the role that climate, and I'm a climate scientist in part by training, and water played in the very evolution of Homo sapiens. The success of Homo sapiens was in part the success of our species learning how to manipulate and survive the vagaries of the hydrologic cycle and the climate cycle. And our success as a species depended on that. The first age included the first empires that were created along primarily the major rivers of the Tigris and the Euphrates in the Middle East and the Indus in India and southern Asia and along China, the big rivers in China. And the first age included the first intentional agriculture when we decided and learned how to irrigate the crops that were needed to support those first early young empires. And the first age included the first rudimentary dams and aqueducts, again, thousands of years ago, as archaeologists have discovered. The first water laws and institutions, the Code of Hammurabi, which is one of the very first legal codes ever discovered, literally carved in stone from ancient Mesopotamia, includes, is that phone call for me? Okay, look, it's 2023. Turn your phones off. The Code of Hammurabi includes laws that penalize farmers who don't adequately maintain their irrigation systems. And unfortunately, the first age also includes the first known war over water, 2400 BC, between two ancient city-states in Sumeria, Umma and Lagash, that fought a war that lasted 100 years, multiple generations, over access to waters from the Tigris and the Euphrates rivers and irrigated land in Mesopotamia. And the first age ended a few thousand years ago when our populations, human populations, outgrew their local water resources and so contaminated and abused their local water resources that we had to start doing something different. We needed new thinking, we needed new ways of dealing with water, and that became the transition to the second age of water, what I describe as the second age of water. And the second age of water is our age. It's the age we all grew up in. It's the scientific and artistic and engineering advances of the Islamic Golden Age in the 900s and the Renaissance in Europe, when the science and the technology and the engineering and the culture and the art developed to help us build our modern societies. It includes the Green Revolution, which I argue was as much a revolution of irrigation as it was what we think of as the Green Revolution in popular culture, as fertilizers and pesticides and crop types. It was a revolution of irrigation that really has permitted us to feed, in theory, 8 billion people on the planet. It was a time when science and engineers and technological innovators like John Snow in London identified for the first time the real causes of some of the water-related diseases. And then engineers like John Leal built the first engineered systems for cities in Jersey City across the Hudson here. In 1909, there was the first major city that treated its water with, in this case, chlorine, and eliminated outbreaks of typhoid. And within a few years after that, every city in the United States was building sophisticated water treatment systems, and cholera and typhoid and dysentery and diarrheal diseases in the United States disappeared, mostly. This is all part of the second age. We learned how to build aqueducts not a few kilometers long, but hundreds of kilometers long, and over and through mountains, and big dams to store water in dry periods for wet period, during droughts, to store water during floods, to protect ourselves, to generate hydroelectricity, and so on. And that second age of water brought enormous benefits to us, to all of us. Again, that's our age. We grew up in this age. And everyone in this room has benefited from the advances of the second age of water. And it's important that we understand and acknowledge those advances. But it's also important to understand that the second age brought unintended consequences. It brought water challenges. It brought a series of water crises that face us today that, again, we've heard a little bit of reference to already and that most of you are familiar with. We know how to provide safe water and sanitation to everyone on the planet, but we have failed to do so. There are billions of, it's the 21st century, and there are billions of people worldwide today that don't have access to safe water and sanitation. And it's not just a problem somewhere else in developing countries. Millions of people here in the United States, in decaying urban centers, in rural areas, in the farm worker and frontline communities of the Central Valley, in Native American communities throughout the West, don't have, and in some cases have never had, safe water and sanitation. And Radhika mentioned that, and Manu mentioned that, and again, you're familiar with that. We know the story of Flint and Jackson, Mississippi, but understanding that here in the United States, where somebody, was it, I don't know if Manu said it, we have the best water infrastructure in the world. Well, some of us do, but not everyone does. And that's a failure of the second age of water. And it's a failure in part, not because we don't have the technology to do that, not because we don't have the money to do that, but because we have failed institutionally and politically to understand that problem exists and to solve that problem. We have institutions that have systematically discriminated in favor of rich and powerful and privileged groups. And this is the challenge of what I call in the book water poverty. The advances of the second age also came about because we didn't know or we didn't care about the impacts of our water policies on ecosystems. In the 20th century, we built our systems and we took water out of those natural ecosystems, and we didn't know or we didn't care about the consequences for the environment. And we took water where we wanted it, and we disposed of our wastes where it was convenient. And as a result, one aspect of the water crisis that faces us now is the impoverishment and destruction of aquatic ecosystems, the death of fisheries, the paving over of wetlands and marshes, the drying up completely of rivers like the Colorado and rivers internationally as well, which no longer reach the sea, the loss of habitat for migrating waterfowl. The most endangered species on the planet are those that are suffering in the aquatic ecosystems that are a consequence of our policies in the second age of water. In the United States, we passed the Clean Drinking Water Act and the Safe Drinking Water Act, in part because of mobilization around the environmental movement in the 1960s and 1970s, two foundational national laws that protect our water, and they're great. And they led to major improvements in water quality, and they continue to do so. But now we're faced with new contaminants that either were never regulated, like PFASs, or that were inadequately dealt with, like lead. Again, it's the 21st century, and there are hundreds of thousands of lead lines. And it's not as though we haven't known for a long time that lead was a bad thing in our drinking water, but we have failed to address that problem. And again, the Biden administration has provided $15 billion explicitly for lead removal, and that's something that we need to move on. Microplastics, all sorts of new sources of pollution. We've had inadequate enforcement of those laws that haven't been brought up to date because our legislatures have not adequately addressed that. And we have growing political and judicial efforts recently to roll back some of the protections we put in place. Again, Radhika mentioned this, but two recent Supreme Court decisions that move us in the wrong direction in terms of protection of the waters of the United States and access to safe water, especially in this case for Navajo and Native American communities. We're now faced with water scarcity. Despite the fact that the Earth has the same amount of water that we had when the Earth was created 4+ billions of years ago, but now there are 8 billion people on the planet, and we have water scarcity in places where it wasn't scarce before because of the way we allocate and use our water resources. It's driven by growing populations, it's driven by growing economies that overpump our rivers until they're dry or overdraft our aquifers in a non-sustainable fashion. And of course, climate change is here. It's Climate Week. Again, I'm a climate scientist. I've worked on risks to water systems from climate for a long, long time. And we know that among the worst consequences of climate change are impacts on water systems. You all remember from second grade the hydrologic cycle: evaporation, formation of clouds, precipitation, runoff back to the land and the oceans, evaporation again. The hydrologic cycle is the climate cycle. As we change the climate, we are fundamentally changing the water system. Higher temperatures means more evaporation means more water in the atmosphere. More water in the atmosphere means more water in precipitation in certain kinds of events. Loss of ice, loss of glaciers, these are all things that have long been predicted by the climate community and now are coming to the fore. And again, as one of the introductory comments mentioned, this has been just an unbelievable year. It's sort of everything, everywhere, all at once kind of a thing going on with water. The extreme events this year ought to be a wake-up call to really understand the role that climate is playing for a water risk. It's time for something new. It's time for another transition. It's time for a transition to what I call the third age of water. And I think that transition's already underway. It's sometimes hard to see transitions when you're in the middle of them. I think 100 years from now, we're going to look back and we're going to understand that this is sort of a really remarkable time. We're in a transition to a third age of water. There are solutions to all of our water problems. And if we're smart, we'll see them, we'll implement them, we'll fund them, we'll scale them up, and we'll overcome the political barriers that are in our way that prevent the transition from happening as fast as it ought to happen. We know how to provide safe water and sanitation for everyone. I said this a little earlier, no new technology is needed. The cost of meeting safe water and sanitation for everyone is far, far less than the cost of not doing so. Costs that are borne by our frontline communities, by women and girls who have to spend their lives collecting often bad quality of water in many places. So the cost, water-related diseases that result from not providing safe water and sanitation. We know how to do this, we can do this. The UN has set a goal of doing this as part of the Sustainable Development Goals. SDG 6 is ostensibly to provide 100% of the people on the planet with safe water and sanitation by 2030. We're not going to meet that goal, I think, if we don't accelerate that effort now. I think we could, and I think eventually we will. So when I say I'm an optimist, I think we will. We just need to do that faster. We can restore natural ecosystems. We can guarantee water for rivers and for fisheries. We can take down damaging dams, as we're doing now. 1,000 dams have been removed in the United States in the last couple of decades, mostly small, uneconomic, damaging dams, but larger and larger ones. And in California now, on the California-Oregon border on the Klamath River, we're taking down in the largest dam removal project in history, 4 big dams on the Klamath River to restore flows for the Klamath, to restore ecosystems and salmon fisheries, especially for native communities up there. There are lots of examples, and we know how to do that, and we need to do that more and more. Farmers in Northern California have been flooding ag land in the winter for migrating waterfowl, and that's been restoring some of the natural ecosystems that had been destroyed in previous years. So there are ways of restoring ecosystems, and we need to do more of that. We can shift from a focus on finding more and more and more water supply from our overtapped rivers and overtapped aquifers, and think about the demand side of the equation. How can we do the things that we want with less water? That's what I call the efficiency revolution. And again, I think we're in the middle of that. How can we grow more food with less water, with smarter irrigation systems? I have a good friend who grows walnuts in the Central Valley of California, and he sits in his office, and on his monitor, he has real-time information about the soil moisture in his field and the operation of his irrigation system and information from satellites and drones about what the weather is going to be. And he can water his walnuts in a very precise way that we could never do before. And his yields are up, and the quality of his product is up, and his water use is down. And there are lots of examples like that. We can flush our toilets and wash our clothes and our dishes with efficient appliances. And many of you are already doing that, and there's much more potential to do that. And this is already happening. In the United States, we use less water today for everything than we used 40 years ago. On a per capita basis, because population has grown, we use a lot less water per person than we used 40 years ago. We're more efficient, our economy's grown, our population's grown, but our water use is declining. That's a fact that most people don't know, and it's a remarkable fact, and it's a remarkable evidence that we don't need to find more from our rivers and aquifers. We can do more with what we have, and it's another indication that we're moving in the right direction and we're in this transition. We can realize that water and energy are very closely linked. It takes a lot of energy to produce and move and treat and use the water that we use. Probably the biggest user of energy in your homes is the energy you use to heat water. And we use a lot of water, it turns out, to produce the energy that we use, especially if we're burning fossil fuels to cool power plants. Water and energy are tightly linked, and if we're smarter about that link, if we think about those things in an integrated way, we can use less energy to do the things we want in the water world, and we can use less water to do the things we want in the energy world, and that helps reduce greenhouse gas emissions. So there's a climate connection there as well. And it can make our communities much more resilient to those climate impacts that now, unfortunately, we can no longer avoid. And we know that water and food are a major challenge. 80% of the water that humans use in the world goes to grow food. That's true in the Western United States. It's true in California, that number, 80%. Much of the food that we grow worldwide comes from unsustainable groundwater overdraft. And that can't continue. That's a sort of a little bit of a nightmare scenario. We have to figure out how to bring that system back into balance. But as I said, we can grow more food with less water. We can reduce waste in the field. We can reduce waste in food processing. We can reduce waste in our own homes and our local food systems. And that can reduce pressure on our water systems as well. We can change our diets. Meat diets are the most water intensive of all. A lot of the food that we grow and a lot of the water that we use to grow that food goes to feed animals. Just a quick number, it takes about 15,000 tons of water to grow a ton of beef. It takes about 1,000 tons of water to grow a ton of grain. 15,000 versus 1,000, because we're feeding a lot of grain to cows. That's a water problem. We can capture our wastewater and treat it to a very high standard and reuse it instead of throwing it away. California already uses about 18% of its wastewater. We treat it, we reuse it. Israel and Singapore treat and reuse about 90% or more of their wastewater. We can do a lot more, and that doesn't require taking more water out of our rivers and lakes as well. And we can capture more stormwater when the storms we get happen and store that water as well. In short, there are solutions to all of our water problems. The challenge is understanding them and implementing them and funding them and scaling them up, from the local level to the community level, to the business and corporate level, to the national level, and so on. And I'm not saying, understand this, I'm not saying this is going to be easy. Difficult decisions are going to have to be made about investments, about agricultural policy, about laws and institutions, which are some of the biggest barriers to our solutions, the role of corporations and water stewardship in the corporate world, democratic decision-making, equity, and fairness. But it's easy to imagine a gloomy, dystopian, disastrous future. The news talks about that all the time, the movies, sci-fi stories and books, I read them all, that highlight that dystopian future. But if we had a choice, we wouldn't choose that future. We choose one where we solve the problems that we face. And that's the point. That's the bottom line. We have a choice. We can choose to solve our water problems. We can choose a positive third age of water. And I think that's a future worth fighting for. As you spend your time here today and as you spend your time moving out into the future back at your day jobs, remember that. Spread the word. Keep fighting as individuals, as organizations, as corporations, as communities, as voters, as members of the public sector. There's a role for each and every one of us. Thank you very much.